calculating power, right? Power is the rate of energy use. So when you think of light bulbs, it might have a 100-watt rating, 60-watt, 40-watt, and that's just telling you how much energy is actually being used by the device when it's on, right? And if you think of energy, we introduced joules, right? So some of you might be familiar with that. The symbol for joules in all your calculations will be capital J. And when you do a rate, right, think of it means like per unit of time. So in this case, per second, right? And when we have a formula for power, it's how much energy is being used divided by the time that the device is working, right? So watts is the symbol, or sorry, the unit of power, and we use W for the symbol, right? And when you break down what a watt is, it's equal to 1 joule per second. To convert between kilowatts and watts, right? There's a key thing to remember. In 1,000 watts, that's the equivalent of 1 kilowatt. So when you know that, we just really have to divide our watts by 1,000 to get kilowatts. So when you look at our example up here, we have 2,000 watts. Well, if we divide that by 1,000, right, you end up with 2. So you just do that for each one, and all I'm doing is taking this number, dividing by 1,000, right? I might round this one up to the nearest whole, 380 kilowatts. Down here, if you have 20 kilowatts, that's going to We will introduce how to convert units of time. This is an essential skill when you're doing the energy calculations, because in our two formulas, we have this energy equals power times time. And in this case, the time is a unit of seconds, right? But we'll notice when we get into calculating energy bills that we use a lot of power in a given month, so that this idea of kilowatt hour comes into play. And so when you read a problem and you see that, you know, the time is in minutes or seconds, you need to be able to convert it to hours, or vice versa, back to seconds. So I'll show you a few little tricks that'll help you with that. First example, we have 5 minutes, and in 5 minutes, it's the equivalent of 300 seconds. Well, we just put the work there, but this is what it would look like if you used this conversion factor of 60 seconds in every minute, right? When you do that, the minutes will cancel and you're left with seconds. So 300 seconds, right? So if I write out the next one, 45 minutes, right? Use the same conversion factor. There's 60 seconds in every minute, right? My minutes cancel and I'm left with a number of 2,700 seconds, right? Our last one, the 17 hours, right? If you think about that, 17 hours, well, I have to do 2 conversions in this step, because for every hour there are 60 minutes, right? There's my hour. And in every minute there are 60 seconds. And now I'm left with this really big number, because I go 17 times 60 times 60, and I end up with 61,200 seconds, right? And if you go back, your hours cancel, your minutes cancel, and you're left with the time of seconds, okay? So one last thing, quick little shortcut for you. The way to remember, if you go hours to seconds, right? Or the other one, seconds to hours. Well, you notice what I did up here. I went 60 times 60. Well, 60 times 60 is really 3,600, right? So anytime I see that, I always go times 3,600 and then divide by 3,600 for the other one. And this little shortcut might, if you can remember it,